Welcome to today's episode of Bits and Bytes. It's just me today. I'm Charlie and I'll be your host. In a previous episode, we chatted about a number of Meshtastic radios and some of their uses. Hopefully you caught that. In today's episode, I'll be walking you through actually installing and configuring Meshtastic on a radio. Solar node from Seed Studio, the P1. The first step for any radio is to ensure an antenna is connected, as the radio transceiver can be damaged if it attempts to transmit without an antenna. Some people have not had any issues with it, but to be safe, just plug an antenna in. Once connected, ensure the batteries are installed. The P1 ships with batteries if you buy the Pro version, but if not, 4 18650s can slot into it. Make sure they're all plugged in the same polarity, positive on the left, negative on the right, as it uses parallel batteries versus serial. The device wants 4 volts. Technically, the device will be powered by the USB bus when you plug it in to configure it, but I prefer a more reliable power source just in case something goes wrong in the host device. If this is your first radio, there may be some preparation needed on your computer to make sure it's set up first. On Windows, make sure you have the right drivers installed for the serial adapter. You'll have to do your own research on that. It may be automatic, might not. On Linux, you need to ensure that your user account has access to the serial device. Plug in the radio via USB-C and open a terminal to check that it has been detected with LS-USB. Over here we can see bus 01, device 12, Seed Technology, Xiaoboot, I think it's called. I think it's how you say it. So it found my radio, no problem. Once you make sure it's connected, check the permissions on the radio with a bit of a difficult command to say out. ls-lha, and you're going to check /dev/ttyacm. ACM all in caps. Some radios will use /dev/ttyusb, depending on the actual serial chip that they have implemented. In this case, I can see my radio, 2 actually, I've plugged in, is owned by root with the group dial out. Make sure that your user is a member of dial out so you can read and write to the serial interface. To do that, if you haven't done it already, again, this is just the first time you set up a radio, you need to make sure your user has permissions. Add your user to the group with sudo user mod tac a tac capital G dial out and your username. Charlie in this case for me. Type in your password, and your user should be added to the group. To make sure that it's applied, restart your computer real quick just to make sure the permissions stick. You can confirm that by typing groups in the terminal. And you should see your primary group, probably the same as your username, and the dial out user. Once you're a member of that group, you can read and write to the radio. So you'll be good to go. Once your computer restarts, open a Chromium-based browser like Chrome, Chromium, or Brave, I believe, and head over to flasher.meshtastic.org. Unplug that one. Pro tip, if you have multiple radios plugged in, ensure you only have one plugged in during this step. The interface is not always obvious as to which radio you're flashing, and that will prevent you from accidentally updating the wrong one. Select your target device. In this case, you're just picking what radio you have. So in my case, it's the Seed SenseCap solar node. And this is the NRF 52840 chipset. Looks like they do have a SenseCap indicator, which is running an ESP32. Don't get them confused. They will use different procedures. So you select that. I almost always run the unstable build, but you are welcome to run the 2.6 beta. But for this example, we'll be using the 2.7.11 alpha build. So you select that, and then you just hit flash. It gives you the changelog. I did a little bit of looking. They do have 2.7.12 release, but then they redacted it because they had some issues with it. Occasionally, you'll run into that. In this device, it will ask you to enter DFU mode. And again, this is where ESP32 and NRF chips will differ a little bit. NRF, they usually get mounted as a drive, as a USB drive. With ESP32, you will transmit the firmware directly to the CPU. So in this one, enter DFU mode. You pick the device. Again, make sure you only have one plugged in so you don't select the wrong one. Connect. Sometimes you might have to click that a few times. Or reload the page entirely. I guess I was talking too slow. Okay, seed, ThinsCap solar, 2711, yada yada yada, enter DFU, pick it. There it goes. And my computer just clicked, indicating that the Zhao boot drive is now mounted. So perfect. And then we will need to ensure it's mounted. Yep, we did. Download the firmware. So we'll download the UF2 firmware. And that's a 1.5 megabyte file, so it should be very quick to download. Then just go into your downloads folder, copy the UF2 folder or file that you downloaded, go into the Zhao boot mount point, paste it, and wait a minute. Get a little notification, copying firmware, takes just a minute. Tick tock, tick tock. There it goes. Copied firmware. And when it copies, it will automatically restart the device, kicking it out of that upload mode, which is fine. Give it another minute for it to reboot and come back online. While you're waiting, close that. You're done with the Flasher interface. You can go to client.meshtastic.org, hit new connection, and by now it should be restarted. Pick serial. Might need to hit new device. Again, pick the Zhao boot ACM0, and it populates in the list. Select it again. And now we have the interface brought up. Firmware 2.7.11, that's what we picked. If you pick the beta 2.6, it will show it there, but the procedure is the same for both versions. It is currently charging 3.9 volts. I would have expected that battery to be higher, but that's fine. It's got plenty of charge in it. They will always come up with Meshtastic 4-digit code. I believe that's the MAC address. First thing you'll want to do is go over to config and then LoRa, L-O-R-A. L-O-R-A. Every radio needs its region set. In our case, it'll be US because we're in the US. For Europe, they use 433 or 868 megahertz. Same thing, China, Japan, you just pick your region. But we'll pick US. I like to increase my hops. The default is 3. I like to go up to maybe 5. I'll keep frequency slot set a default at 0. That can be useful if you need to adjust your frequency a little bit. We'll get into that more later. And then pick whether this device is okay to MQTT or Mosquito. What that will do is it will attach a flag on transmissions saying text messages and data sent from this device are okay to send on the Mosquito IP network. Up to your call if you want to enable that or not. We'll go ahead and enable that here. Everything else should be fine for defaults, I believe. And we'll go up and just click Save. It may restart again. Not sure. Refresh the page. The ESP32s will restart every time you update a setting. I'm not sure if the NRF chips will, but you may sometimes have to refresh the web browser to get it to display the updated information. But we got the region set. Now we can go over to nodes, and nodes are starting to come in. So in theory, if I go into my phone, open the Meshtastic application that I have paired to another radio, and just send out a test message. Test. It saw the broadcast immediately. Doesn't have timestamp set. We'll get there. And is that my device? A68D? Yeah. Yep, that's my device. So it's all my device. So it's, oh, and somebody replied. How perfect. Congratulations, FEB4, you're on the stream. Reply, thanks. Yep. And again, I am sending all of this via my phone, but because it's Meshtastic radios, they all see each other if they're all on the same frequency. That's where that frequency offset can be useful too. If you don't want to be on the same frequency as everybody else, you can change it to be in your own isolated radio space. Some people prefer to do that. Some people like to be on the public network. Your call. One disadvantage, if you do change the frequency, I do not believe other radios will rebroadcast your message. So it will only be radios configured for your frequency slot that will rebroadcast your message. And that's simply because the radios aren't listening on your changed frequency. And there's a whole list of default ones that we'll get into in a moment as well. Now that we have messages coming in and nodes starting to pop up, let's go back to config and look at some more of the settings. Under device, the role plays a major part in how the device operates. Most of the time you'll want to leave it as client. That's the standard default setting. Client mute can be useful to indicate to not message that device, or messages sent to that device will not be checked, I think. Client base is the new option they just added in 2.7.10. It is meant to act as a router for known favorited radios, such as your own personal radios that may be nearby, and will act as a standard client for any unknown radios. The idea, I believe, is that if you have a base station on your roof that you want devices inside the house to transmit out through, it will act as a router or a repeater for them, so that it helps with the propagation. I'm not exactly sure why. I haven't read into it, but looks like an interesting setting. Other options, router client, repeater, tracker. Yeah, but for now we'll stick with client. Um, the firmware supports multiple features like buttons and buzzers. The sense cap from Seed features a buzzer, so it will ding when you receive a message. You can change to override that. How to handle rebroadcasting could be useful if you need to adjust it. Usually leaving it on default is fine. Broadcast node. This one can be useful. As we see over here, many of these nodes are coming up as unknown because this new radio I just plugged in doesn't have their node information, like their name. Yeah, pretty much their name, actually. Because it wasn't online during a node information broadcast from that device. So by default, it is set to 10,800 seconds or 4 hours. So every 4 hours, your radio will send out a broadcast with its name and basic information. In order for a node to get your name, it has to be online and connected during that interval. So I like to lower this to maybe 1,800 for a half hour or 3,600 for every hour. Depends how frequently the device is moving and how frequently other nodes are moving past it. So for example, if it's a car, you might want to set it to every 5 minutes. And if it's a stationary node with other stationary nodes nearby, you're probably fine leaving it at the default value. But we'll go ahead and lower it to 3,600 or 1 hour. This device doesn't have usable buttons, so we'll skip those. The time zone is another interesting one while we're on this page. That is referring to the POSIX time zone list format. They are not exactly user-friendly. For example, you would think in here you might type America/New York. Can't even spell York. But that won't work. I don't think so. Instead, you have to use the code. In my case, because I'm on Eastern Time, the code for that is EST5 EDT, M3.2.0, M11.1.0. I have no idea what the hell it means, but you'll have to look up in the database that we will link. Once you do that, go ahead and click Save. There we go. Position, another useful setting. Most radios ship with GPS, and the P1 Pro is no exception. It ships with a GPS module or GLONASS, global location, I don't know, GPS. It has a chip and chip and antenna attached already out of the factory. If you get the P1 Basic, it does not include the GPS module, but you can purchase and install it separately yourself. Because I have the Pro, it does come with that module, and it found it and automatically enables it. I don't believe we need to change anything here, but again, the broadcast interval for location can be useful if it's a moving device that you want it to update more frequently or less frequently. But for standard operations, the base settings are sufficient. Power. I have had very bad luck with power settings, power saving, so I generally don't adjust them. The ESP32 chips have a tendency to go to sleep and just never wake up. And actually, I think NRF chips have had similar problems. So I generally just don't enable power saving at all. Leave it all blank. Leave it all default. Network. The Seed P1 does not support a network adapter. It does not have any network wireless chips on it. ESP32 devices usually do, but you'll have to be careful with them because they share the same circuit as the Bluetooth. So only one can be enabled at a time on ESP32 chips. Some may have two separate chips, but most of the ones I've seen from Heltec, at least, they share the chip. So as soon as you enable Wi-Fi, it will disable Bluetooth. So you need to be careful about that. But because this one doesn't have any, there's nothing to do. It also doesn't have any Ethernet ports on it, so nothing to do there either. Display. Again, the CP1 doesn't have a display. Nothing to do here. Bluetooth can be useful. The P1 does have a Bluetooth chip, and that is probably how you'll manage it from your phone. Since it doesn't have a screen, Meshtastic devices that don't have a screen ship with a default pin of 1, 2, 3, 4, 5, 6. Should probably change that to something. So pick a good pin that you like. A random pin will not work because there's no screen to display the pin. So don't do that for this device. Security. That is useful because that's where your RSA, your RSA public and private keys are available. When the radio send out a message, they encrypt it with their private key that other devices can download their public key automatically to decrypt the message. Or signing. Yeah, something like that. Yeah, to communicate with a device privately, your radio first acquires its public key that it can use to encrypt a message to, and the receiving device can use its private key of the symmetrical pair to decrypt your encrypted message. There's a whole thing of it. But yeah, encryption is enabled by default. Additionally, you can set a primary administration key, which would be the public key of your personal carry device. This can be useful because it allows you to connect to the remote base station over your existing radio that you may have on you to manage it over the lower network. The problem with Bluetooth, you have to be basically right on top of it to control it. LoRa is substantially further distance. You can be down the street, across the county, depending. So by setting your public key of your personal carry on the base station, you can manage its settings and control it a bit across the network. It's not as fast, but it is reliable enough if you have a good connection. Do not set enable or managed. That will only allow you to manage via the lower network, disabling Bluetooth, which if that's intentionally what you want to do, you can do it, but remember that as soon as you set managed, you will not be able to connect to it via Bluetooth. Don't worry about legacy admin channels. Those are being removed. By default, they ship with logging over the serial bus. That can be useful if you're on site with a laptop trying to diagnose something, but not much use otherwise. Other than the core radio configuration, they also have module configuration. Modules are extended pieces of functionality, additional to the actual use of the radio. Features like the MQTT settings, where you can broadcast to a different Mosquito server. So you can have that be for your own in-home network, where it directly connects with your network instead of the public mesh network. That could be really useful. Serial settings, external notifications, that's useful for devices like the SenseCap from Seed, but not so much for that one. So we'll kind of skip over most of these because the P1 doesn't have much support for anything actually. Channel config, another extremely useful setting. By default, Meshtastic uses the pre-shared key of 8Q equal equal on an 8-bit encryption. Very minimal, basically none at all. That's the default encryption for radios. By radios sharing that same key, it allows them to communicate in a pseudo-encrypted method, but not really encrypted because it's a publicly well-known key. But you can change that to your own private key if you want to establish a private network. That can be particularly useful if you want to track your personal devices and share their location without sharing the location to everyone. So what I like to do in that case is I will take the public channel, go to channel 1, enable it as a secondary, and set its encryption to the public one. And then I'll go and give it a name of, I don't know, public or some such. And then its location can either be do not share or 23 kilometers, something obscure. So we'll just set do not share for now. Click save. Wait for it to do its thing.
A few minutes later.
It should have responded by now. Refresh the page. Channel config. Yeah, it didn't even save it. Okay, sometimes that happens. Try that again. Secondary, set the key. 8-bit encryption. Yep. Okay, it took it that time. So yeah, set the public channel information on channel 1, and then go back to your primary, and there you can generate a new private key or enter your existing pre-shared private key for your private network. And then in there, share your precise location. So what that will do is it will send your precise GPS location to your private devices using your private encryption, but not send it to the public network or send an obscured location to the public network. One thing to remember for that is that doing it the other way around does not quite work. When the radio sends a GPS update, it will go through the channels in order, primary, channel 1, channel 2, etc., until it finds a channel that has GPS enabled. Once it hits that, it will send the location with that channel's precision config, be it precise or very obscure, on that channel, and then exit. So if you have your private channel as channel 1, a secondary channel 1, and the public channel on the first one, both with the location enabled, your private will never actually receive location updates. It's intentionally built like that, but it should probably be changed because it's not very obvious. So that's why when tracking locations for personal devices, I like to set the public channel down one and use the private primary to share location. And by having the secondary as public, you will still be able to participate in that public network as well. One thing that needs to be remembered is that if you change the name of your primary channel Well, we'll just go ahead and do that. Refresh to make sure. It didn't even save it. Thank you. Try that again. Yes, regenerate. Some private. Save. Yeah, you have to be slow with configuring, especially with the web interface. It doesn't always save your settings. Or at all, because why is it not saving? Is it because I'm putting a space in the channel name? Let's just say private ch. Save. And refresh, make sure it's stuck. Okay, so no spaces in the channel name. Otherwise, it just ignores your request. So I changed the name of the primary channel. That means the frequency would have also changed. So it used to be that when you change the channel name on the primary, it would change the frequency the device operated on. So on long fast, it would no longer operate on 906.875 megahertz. But now it still is operating on that, even though the primary channel name changed. So maybe they fixed that in the newest version. Yeah, slot 20, 906.875, yeah. Cool, good to see. But on 2.6, it might still change the channel. So if it does deviate off of the default channel or your community's channel group, some communities may operate on different channels. And the channel presets, which I'll get into in a moment, also have different frequencies. Long fast, which is what they ship on by default, is slot 20 or 906.875. If you change it to short turbo, for example, which offers 20 times more bandwidth, its frequency is 926.75. And those are configurable. Different communities will have different bandwidths and different channels, maybe, or you can set your own. That's where that can be useful. But yeah, Central Ohio currently is the default slot 20. You'll want to make sure it's set there if you want to participate in that. This node, this is going to be bit 2, I believe is the name that we're going to go for it. So change device name, and its name will be the bits in bytes.dev base 2 with the tag bit 2. And short names for radios can only be up to 4 characters, or in the case of some people around here, an emoticon, if you really want. And the name can be up to 40 characters. So, and both will show when you're viewing a tag. So we'll just save them. And in a few minutes, that should update to other devices. Should being the keyword. Yep, it took there, just had to refresh the page. And it actually updated over here, that's good. Do a cheeky message. Yep, it still works. Great. Well, thanks for watching, and hopefully this has helped you with your own Meshtastic radio setup. For more details and other reviews of radios, tech, gadgets, and whatever else we may happen to come across, head over to our website, bitsinbytes.dev. bitsinbytes.dev. Find us on Mastodon, and stay tuned for our next episode where we hopefully get this radio set up on an actual rooftop. Have a good one.